Hello everyone, on this part we will cover 5 number summary and box plots. What are these 5 numbers? These are exactly what we had in the previous section. We have minimum value, maximum value, Q1, Q2, Q3. So this was median or Q2. So exactly same thing that we covered in previous section. And for inner quartile range, you already know that that is equal to Q3 minus Q1. And this one was median of the first half. Because here on the side we have lower 50% and here is upper 50%. And the Q3 is median of second half. Now example, here we have this data on the table. Every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the US. The following data are the interest rates. So these are interest rates charged by 10 credit cards. So we have, in total, we have 10. And these are randomly selected for the July 2005 survey. We should find 5 number summary, finding what minimum, maximum, Q1, Q2, and Q3 is. We can use TI-84, so using TI-84, or you can use StatCrunch. We want to find minimum, Q1, median, or Q2, in Q3, and maximum value. Okay, first I'm gonna try calculator. Steps are exactly same. First, press that. We have this one. Then choosing the first edit, enter your data in L1, one column. We have 10 numbers here because we have 10 credit card users. So after that, press that, choosing calculate. We should have the first one for stat, enter. Then after this, again, enter, enter, enter. So 3 times. The result is, here we have mean. It didn't ask us to find mean or standard deviation. We only need to find minimum Q1. So I'll scroll down to see those data. So it's same screen, it's on the same page, but you need to scroll down. Here is our minimum value is 6.5. Q1 median of first half is 12. Our median or Q2 is 13.6. And these are in percent because our data was in percent. So Q3 is equal to 14.4%, and max is 14.5%. So this was using TI-84. Now using StatCrunch. So when you enter into your StatCrunch after you signed in, exactly same as what I did in previous section, open that yellow box, open StatCrunch. After that, you have this page, enter your data into this column. I changed that name and I entered L1. So you can change name for that. Enter anything you want like that. Since I had L1 into calculator, I use same thing. Then after that, we have these data. After that, stat, summary stat, columns. Choosing that one, you should have this L1 here on right side. Okay, now let's see what we have here. I have Q1, Q3, mean, max, median. It didn't ask me to find inner quartile range, and in calculator I didn't have that, but let's choose that one too. So we have Q1, okay, inner quartile. So to that part, I'm choosing all these. Now we have inner quartile range on right side. Then compute. In total, we have 10 numbers. Mean is mean is 12.62 exactly, and same as TI-84. Then standard deviation 2.58, 57, so same thing. But here we rounded. Median or Q2 is 13.6, so it's same. We don't need range for this part. Minimum value is 6.5, maximum value is 14.5, Q1 is 12, and Q3 is 14.4. Inner quartile range is Q3 minus Q1. So Q3 minus Q1, that is 2.4. So we have same thing. Now writing all these. So for minimum value, we got 6.5%. Here is 12%. 13.6%. 14.4. And finally, max is 14.5. Okay, so these are 5 number summary. Next page. Draw and interpret box plots. So here we have box plots. Step 1. Determine what lower and upper fence is. So finding lower fence and upper fence, and also inner quartile range. So same thing as the previous section. Step 2, draw a number line long enough to include the maximum, minimum, Q1, Q2 or median, Q3, and then draw box. So to draw this one, we need to find median, Q1, Q3, and min max. Step 3, label the lower and upper fences. Step 4, draw a line from Q1 to smallest data value that is larger than the lower fence. Draw a line from Q3 to the largest data value that is smaller than upper fence. These lines are called whiskers. So we're gonna follow all these steps to draw this box plot. And then finally is outlier. So any data values less than the lower fence, less than lower fence or greater than upper fence, these are outliers. And for outlier, we're going to use this like star. We're using that one. So we use asterisk for that. For example number 2, after giving a statistic exam, Professor Yang determined the following 5 number summary of her class results. This is a result. Use this information to draw a box plot of the exam scores. Okay, so these are our data. These are not 5 key numbers. So these are not what we have 5 number summary. These are the data. So following steps, we want to draw box plot. So first step, find the 5 number summary. But that means finding smallest data value, so mean, max, median, or Q2. Here we have Q1, and this is Q3. Okay, so minimum is 60. Max, these numbers are in order. Max is 98. Now finding Q1. Q1 is equal to 60 plus 68. Divided by 2. Q2 is 77. So we don't need to write that one. Here is Q3. Q3 is 89 plus 98 divided by 2. So the answer for Q1 is 64. And Q3 is 93.5. Here we have 77. That's how many numbers we have. N is equal to 5. That is odd. So this is median in between. That is 77. Now Q1, 64. Median of first half. And Q3, 93.5. Let's also use calculator for this part. So again, press Start, choosing Edit, then Enter, Now enter your data in first column. So what we have is numbers are 60, then enter, 68, enter, 77, enter, 89, enter, and finally 98, enter. We have these 5 numbers, and after that, stat, choosing this one, number 1. So again, we have this one, enter, enter, enter. Scroll down. The answer for minimum value is 60, Q1 64, median 77, Q3 93.5, and max is 98. So exactly same as what we did without using calculator. So here are the answers. Now second step. Find fences. So find the fences. For that we're finding inner quartile range first. Inner quartile range is equal to Q3 minus Q1. And Q3 is 93.5 minus Q1 is 64. So that is equal to 29.5. Now after that we can find upper fence and lower fence. So first upper fence is equal to Q3 plus 1.5 times inner quartile range, and lower fence is Q1 minus 1.5 multiplied by inner quartile range. Q3 93.5 plus 1.5 multiplied by inner quartile range is 29.5. First multiply these two. So you should follow order of operation. We have multiplication first and then we have addition. So multiply and then add. The answer is 137.75. Now lower fence, 64 minus 1.5 multiplied by inner quartile range. So that is 19.75. Now, after we compute lower fence and upper fence, now we can say if do we have outlier or not. So compare these two with minimum and maximum data value. So if we had any data values less than the lower fence, so that is the smallest that we have, and that is not less than this lower fence. And also if we had greater than the upper fence, so let's see, if do we have greater than upper fence, this is 98, so that 98 is not greater than upper fence. But that means we don't have outlier. So no data points are outside this range. That's why we don't have outliers. So no data points outside of these two fences. That means no outliers. Now third step. Now we can draw this. We need number line. Okay, based on numbers that we have here, I'm choosing these on number line. So we have 50, 60, 70, 80, 90, 100. So the numbers that we have, median is 77. So this is 75, 77. This one is 77. I'm drawing vertical line. This is median. Now Q1 is 64. This is 65. And here is 64. Same thing, draw a vertical line. And Q3 is 93.5. So this is 93.5. This one Q3, here Q1. Now connect these to draw box plot. And also our max is 98. So this is how we draw max. And minimum is 60. So this is 60. So this one is max. We don't need to write it, so we usually use these, but that's fine. We can write this one max, and this point is mean. Okay, here I said that we don't have outliers because no data points are outside of our fences. And that's why we don't need to draw our lower fence and upper fence. So No need to graph. Usually when it's asking to draw a box plot, we only need this 5 number summary. So no need to graph fences. If no outliers. So if there is no outliers, unless told us to do. Okay, now next page here. On this board we have skewed right, skewed left, and bell-shaped. Okay, we already had all these in previous sections. Now instead of these histograms, we have box plots. So this one on the left we have skewed right. Here is symmetric, bell-shaped, and this one is skewed left. Remember that when we had skewed right, mean was greater than median. For bell-shaped, or here we have symmetric, mean is equal to median. For skewed left, mean is less than median. So these points are our 5 number summary. We have minimum Q1, Q2, Q3, and max. And we have same points here on this part, which is using histograms. Okay, now example, use the side-by-side box plots to answer the questions. Okay, what is this one? This part is minimum. Here is max. That one is, sorry, this is outlier. This part is Q3, median or Q2, Q1. Now same thing for this box plot. This is Q1, Q2, or median, Q3, max, mean, and no outlier. Part A, to the nearest integer, what is the median of variable x? Okay, so this is x, and that is our median. Use this number line and find the answer for median. Okay, so that is 16. Median is equal to 16. Okay, and also based on what we had on top, I want to see which one is skewed left, skewed right. It didn't ask us, but let's see which one is. For the first part here, okay, can you see that? This one is median. and mean is it's somewhere here. So mean is greater than what we have for median. Now same thing for this part. This is skewed, right? This is skewed, right? And mean is greater than median. But this part, this median is here on the side, on right side. So that is skewed left, and mean is less than median. Hope you remember these. Let me write it. So I'm writing it. What we had for skewed right was that we had longer right tail. So the right tail is longer than what we have on left. So long right tail. And here we had long left tail. Okay, now we can work on part B. To the nearest integer, what is the first quartile? So what is first quartile of variable y? So working based on the second part. And this is first quartile, finding Q1. So that is 22. Now part C, which variable has a more expression y? So for that one, we need to compare these two box plots. Obviously, this variable y, this box plot here, is wider than what we have here for variable x. So the answer for this one is the variable y. And that is because the box plot has wider range. Now part D, does the variable x have any outlier? If so, what is the value of the outliers? So this is x, and this was, here we have that star, and that is outlier, so the answer is yes. And the value for that one is, what is that one? Here we have, it's about 30, so we can say that is equal to 30 or 29. I think it's 29, yeah, it's very close to 29. So yes, the value of that part is 29. So yes, we do have outlier, and that is the value of 29. Now part E, describe the shape of the variable y. We already covered that one. So the variable y, what is the shape for that one? That is skewed left. So the shape of y is skewed left. Shape of y is skewed left, and that is because what we have on left is left tail is longer than what we have on right. That's how we know that that is skewed left. So the left tail is much longer than the right, and the median is to the right of center. Okay, we finished this part.